Now you just finished graphing the function y equals x squared plus 2, didn't you? And you discovered that the graph of that function took the graph of y equals x squared and shifted that graph up 2 units. So in general, whenever you add a positive constant to the squared term, it will move the graph upward that number of units that you've added to the squared term. So now we're going to take a look at what happens when we subtract a positive constant from the squared term, and we're going to look at y equals x squared minus 4. Now you probably can anticipate that what that will do will be to take the graph of y equals x squared and shift everything down 4 units. So what we'll do is to set up a table, which you can see below there, and we'll plot some specific points to confirm that. And I'm going to use the same x values here that you used in the table when you graphed the function y equals x squared plus 2. And what you probably will want to do is to try to fill in the values for y here before I do it, just for practice doing the computation on your own. Now I hope your values for y match those that you see in the table. And if you were to take and plot those points that you see in the table, you will get then the graph that you see in red below. Now let's next determine the coordinates for the vertex. And you know when a parabola opens up, as this one does, that the vertex will be the lowest point on the graph. And I think you can see that that will be down here, where I'm putting it in green at the point 0, negative 4. So that will be the vertex. Now the axis of symmetry, you know, is a line that divides the parabola in half. And if you were to fold the graph over that line, the two halves or pieces of the parabola would match up or coincide exactly. And also remember that the axis of symmetry always will pass through the vertex. So for us, I think you can see that the axis of symmetry actually will be the y-axis, and the equation for that will be x equals 0. Now for the domain, remember, will be the possible values for x that you can substitute into the function. And if you go back to the original equation, I think you can see that any possible x value is legitimate because it will always produce a real number. But also from the graph, you can see that the graph will extend as far to the right as we would like and as far left as we would like, which means that the domain will be all real numbers. So in interval notation, we can express that by writing then negative infinity to infinity. And the range will be the possible y values, and you can see that the smallest y value here actually will be negative 4, and all the other y values for points in the graph will be larger than that. So then our range will be from negative 4 to infinity. So in general, whenever you subtract a positive constant from the squared term in a quadratic function, it will have the effect of taking the graph of y equals x squared and shifting the graph down the number of units you subtracted.